Kinetic model of matter. Have you learned this? When did you learn it? Anqi? Okay, yeah, so when did you learn this? Kinetic model of matter? Besides last year lah. I mean, you know what I'm talking about. When? This year, when? Early this year, which subject? Chemistry, right? Have you all learned this in physics in your lower sec? Lower sec. Have. Okay, so all of you should have some prior knowledge already, right? So let's see. What are the states of matter? Solids, liquids, and last one, gas. Okay, have you heard of the term fluids? What are fluids? Only liquid? No. Liquids and gases, these two are fluids. No, it is not just used for liquids. Fluids are used for gases as well. Okay? So these are the three states that we are interested in. Does anybody know of any other states? Huh? No? No, molecules are not states. Huh? No, that's also not state. Who has heard of this? No. Plus? This one. This is another state that is not in our syllabus. Okay? When we ask you for states of matter, I only expect these three. Don't give me plasma. Huh? You gotta find out yourself. Okay, so just information only, more than 3 states. Okay, so we are very familiar with these three because we also learned them in primary school, right? So what comes to mind for solids? Okay, so you're telling me example is ice. So might as well tell me an example of the rest lah. Liquid. Water. Okay, steam. Or water vapor lah, okay? So what else can you tell me about these 3 states? Say. Move randomly. What moves randomly? Gas? Particles, okay. Particles move randomly. Later we will come back to this word. So what else can you tell me about the rest? What about liquids? How do the particles move? What have you all learned in chemistry? Move what? Slide. Move slightly. Or slide over each other. Okay, also short distance. Okay, anything else? Okay, let's talk about ice. What did you say? Vibrate and rotate. Anything else? Closely packed. Okay, so now you're talking about arrangement, closely packed. Or very. Okay, then what else can you tell me for liquids? So closely packed, okay? So this one is very closely packed, this one is closely packed. Okay? And for gases? Far apart. Okay, do you all have the same chemistry teacher? Did any of your chemistry teacher tell you about this word randomly? What did they say? They ask you to use it? Arif, what did your chemistry teacher say? Whichever year lah. Move rapidly. Move rapidly. Rapidly in all directions. Any. Any more? Any other variations that you all know? Freely. Okay, blue color, freely. Anything else? Anything else? Okay, so what is the difference between freely and randomly? Let me just compare these two. Think about it. What's the difference between freely and randomly, and which one should we use? Gaius? What's the difference between freely and randomly? Is there a difference? Freely means I am not holding on to it. You're free to do whatever you want, right? That is free. But randomly means there is no particular pattern at all. We cannot predict it. That is randomly. But freely, you can have a choice. You can do whatever you want. Okay? So the particles, you say that they are moving freely / randomly. Do you know how we can prove that they are actually moving they are moving freely or randomly? What is this? What is the experiment that we always use? Okay, what do you see in the microscope? I'm sure you can't see the gas particles, right? So what is that experiment that allows you to conclude that your gas particles are moving quickly? It starts with B. Brownian motion, right? You have some smoke particles that you observe under a microscope. You see that they are moving in all directions. So what causes them to move in all directions? The air particles, which themselves are also moving. But are the air particles moving randomly or are they moving freely? Yeah? Listen carefully. Everybody listen up. Air particles, are they moving randomly? That means they have a mind of, moving randomly means no particular order. I want to go here, I just go here. I want to go there, I go there. Randomly. You can't predict. Do they have a mind of their own? Or are they moving freely? That means if I get knocked by somebody, then I will go there. If I get knocked by somebody over there, then I will go there. So is it freely or randomly? Who say randomly? Who say freely? Okay, it should be freely. They are moving freely. They don't have a mind of their own. They cannot decide to go here and go there wherever they want. They are moving freely because they are being knocked by other air particles. Even when I'm talking now, there is sound, right? Sound comes about by the vibration of the air particles in the air. So my voice, you can hear it because of the vibration of the air particles. So they are moving because of a reason. Can be me speaking, can be you running, can be the fan turning. So these causes the air particles to move freely. Nothing is holding them back. Okay, a little bit, but generally quite free. Okay? So what else have you all talked about? You talked about the arrangement. What are you all talking? You all have something to discuss? Or you all learn something new? In purple color, these are the arrangements. Over here in green, these talk about how they move. Okay, so the summary is given in page 125 of your textbook. The different states of matter, they have different arrangements. So in your solids, they are closely packed together in a regular manner. Very regular. That's why they have a fixed shape. Okay, they all have somewhere to go. Then, because they are closely packed together, they occupy minimal space. Makes sense, right? You pack everything closely together, they occupy the least space. So this results in them having the highest density. Okay, so listen to this question. One molecule of ice versus one molecule of water versus one molecule of steam. Do they have the same mass? Do they have the same mass? One more time, one molecule of ice, one molecule of water, one molecule of steam. Do they have the same mass? Are they made out of the same thing? What are they made up of? One what? One atom of oxygen and two molecules of, and two atoms of hydrogen, right? So whether it is ice, water, or steam, one molecule of each of these three is made up of one atom of oxygen, two atoms of hydrogen. They are the same thing. So they have the same mass. Okay? Then there is a difference in the way they are arranged. So generally, for any substance, but I don't want to talk about water because water is a bit different. For any other substance, your solids, they are packed very closely together. For your liquids, they are randomly arranged. Should we say randomly? They are not packed closely together, slightly further apart. And therefore, they have slightly smaller number of particles per unit volume compared to solids. Because they have a bit more space in between them. The same number of particles in solids and liquids, they will occupy different amount of space. Your liquids are going to occupy a bit more space than the solids. So given that the mass is the same, if mass is the same, but volume is greater, what can you tell me about the density? Volume greater, mass same. So what happens to the density? Density is equal to mass over volume. So when your mass stays the same and your volume increases, what happens to the density? Yeah, it drops, it decreases. So generally, we say that liquids, they have lower density compared to solids. But the difference in the volume is just a little bit only, right? That's why we still consider them to have high densities for liquids. But we now compare it with something very different, gases. Gases, they have a lot of space in between them. How do we prove that there is a lot of space in between gases? How can we prove that? Yes, they can be compressed. In your primary school, you use a syringe, right? So there is air inside. You block the outlet, and then you can actually compress the air inside. So that tells you that there is a lot of space in between your air molecules. Okay? So since they have a lot of space in between them, the same number of molecules of a gas, they are going to occupy a lot more volume. Since now, for a gas, the volume increases, what can you tell me about the density? It is going to be very low. That is why in page 125 at the bottom, the last bullet, it says the gases have very low densities. The reason is because they are very far apart and there is a small number of particles per unit volume. We compare one unit volume That will be, in SI units, 1 cubic meter. For 1 cubic meter of solid, it is going to have a great mass because we are packing them very tightly and closely together. For 1 cubic meter of liquid, we are going to have slightly less number of molecules in the same volume because there is a little bit more space in between them in liquids. Whereas for gas, in the same 1 cubic meter of space, there is going to be much fewer molecules, resulting in a lowest density. Okay? Then for particle movement, so we said that, you told me that they vibrate and they rotate. Yup, they vibrate, they rotate about their fixed position. That is how they can stay packed together in a regular pattern. So they have, you didn't talk about the forces. Forces between them. Okay? They have very strong forces. That is why we can hold them together very tightly. Then in liquids, they are free to move about within the liquid. There are attractive forces between the particles, but not as strong as compared to the solids. And that is why they have a fixed volume, but they take the shape of the container. They are free to occupy the space that they are in. Then forces, you also didn't talk about it. Generally still strong, but not as strong as compared to solids. And finally, for your gases, they have very little attraction between them. That's why they are free to move about. And they move at very high speeds. Okay. That's why they have no fixed shape, no fixed volume. And you can compress them easily. Any questions up to this point? Then, out of all these three states, the descriptions, the characteristics, what is one common word that keeps appearing? Particle. Particles. We are describing how the particles are arranged. We are describing how the particles move. Okay, so all three states. Of course, they are made out of particles. These particles, they are your atoms and the molecules. Okay? Then, look at page 125 in gray. There's a gray box. What does it say? What does it say? Okay, your kinetic model of matter. So, Gaius, what do you understand from the word kinetic? What do you understand from the word kinetic? What comes to mind? You don't need to give me the definition, just tell me what comes to mind. Movement, yes. Okay. So kinetic, he thinks about movement. What else do you think about? Motion. What else? Speed. Because this is like kinetic energy, isn't it? We used the same word in the previous chapter, kinetic energy. And when we talked about kinetic energy, we have half mv squared. So the things that we are interested in will be your particles, which have mass. We are interested in their speeds. Okay? So, matter, they are all made up of particles. And this is a model. Its name is Kinetic Model of Matter. It describes how the particles are arranged. It describes how the particles move in the three states. So it says, the tiny particles, referring to your molecules and atoms, that make up matter, they are always in continuous random motion. Okay, whether it is solid, liquid or gases, they are always moving. Okay? models over here, they are used to represent, to simplify things, to represent something that can be quite complicated. When was the first time you came into contact with this word model? Primary school. When do you use this word model? Mathematics. They tell you, they give you a problem sum. And then your teacher asks you to draw a model. So it can be something complicated like, James has $10, he gave half of it to his brother, use the remaining whatever. Then you draw a model, the model helps you understand what is happening. Right, Yang Kun? Right? Guess what? What do you ask? I talked about what models are. They are diagrams, they are ideas that simplify concepts for us. So in this case, our kinetic model of matter tells us, gives us an understanding of what is happening for the particles in the three states. Okay? So next page, page 126. Okay, Haley. Which state has the greatest force of attraction between the particles? Solids. Afiq, which state has the weakest force of attraction between the particles? Gases. And Yang Kun, which state has the greatest distance between the particles? Gases. Junior, which state has the smallest distance between the particles? Solid. It's all very easy. So I assume you're all doing this without referring to your notes, without referring to your textbook. So the general concept, you should be quite alright. Then we also talked about the evidence of molecular motion. How are we so sure that your gas molecules are moving in freely? So we use the Brownian motion in your investigation 7.1 on page 127. You have a glass cell. So basically a glass box with smoke particles inside. If you have no knowledge of kinetic model of matter, do you expect the smoke particles to move? No, right? You expect them to just stay where they are. However, in reality, when you look at it, you see the smoke particles moving about seemingly in a random motion. And it looks like magic. So there must be something that is moving them, because in science there is nothing called magic. Something is pushing them. What is pushing them? Something that we can't see even under the microscope. The air particles. They are too small. So these air particles, they are the ones that are moving and pushing and bumping your air particles. That's why they appear to be moving in a random motion. So when I ask you to draw what you will observe, and these are questions that can come up for our exams. Draw what you will observe under the microscope for smoke particles in a glass cell. Should we draw this? Does this look like a random motion? No, right? So we should mix it up a little bit. Draw a few more arrows. Then maybe this one we don't want to start in the same direction. We can move in this direction, then this direction. Okay? So smoke particles, I've got 3 particles over here. I can add on more arrows to make it look as though it is random. What we don't draw are your air particles that are bumping them around. These over here are your smoke particles. Okay? Okay, so now on page 128, temperature affects molecular motion. Do you know how it affects molecular motion? Now I want you to imagine, if you are inside a freezer, okay. If you're inside a freezer you are trapped inside, you get cold, then you will start to slow down your motion, and then you just end up sitting in one corner, and unfortunately, if nobody saves you, you die lah. Okay? Because the energy, the amount of energy inside the body, in this case, it could be a cup of water that you place inside a freezer. Your particles inside, the particles in the water, they are moving, right? They are quite free to move within the liquid. But as the temperature drops inside the freezer, what happens to the motion of the particles? They slow down. They slow down, and eventually your water becomes a solid. And what do we say about the movement or the position of the particles? They are going to be vibrating at their fixed position. So they are not moving as much anymore. Okay? When temperature drops, your particles, they don't move about as much as before. So let's compare the other direction. Let's say you have water and you put it over a fire. So the distance between the water molecules is quite small when it is in your liquid state. As you supply more energy to it in the form of heat, temperature rises, they start to gain more energy, they start to move about more. So your temperature has an effect on motion of the particles. Next lesson, bring your TYS, bring your textbook and your workbook. We're going to talk more about this, and we are going to go through, the next lesson is tomorrow, right? Okay, homework for today, I want you to do topic 7, all the MCQ, work energy power, by tomorrow. Yes, topic 7, work energy power. TYS MCQ. Due tomorrow.